had a house full, so I'm not sure if that's a gift or a curse, but we're going to go with gift right now. Today we are talking about data literacy, which is the topic that you should be hitting after winter break, right after winter break. So we thought we would give it to you now so that you had some time to digest it as you are potentially, well, let's find out actually where you are. So we are asking, we're going to practice a little thing. So you might see this waterfall icon over here on the left. And we're going to use a strategy called 3, 2, 1 waterfall. So it's going to involve the chat. And what we're asking that you do is you type into the chat, but don't send yet, which topic you are currently working on with your grade 7s or your grade 8s in math. But don't press send. Just type it into the chat, have it all there perfectly ready. And then I am going to, where are you? Here you are. I'm going to look at the chat. I'm going to say 3, 2, 1 waterfall. When I say waterfall, you're all going to hit send and we should see a waterfall of chats. How cool is that? Let's see if it works. 3, 2, 1 waterfall. Wow. Okay. That's good. Everybody, most people are in spatial sense. That's kind of where we're expecting most of you to be. Chris is already in adding and subtracting fractions. Keener. Okay, cool. Let's go back to the slide deck. Thank you for that. That helps us determine if this is legitimately just-in-time PD, when the next just-in-time PD should be happening. Okay, so a reminder of who we are. These are the faces of Learning Support Services. You have with you today Michelle Lang and myself, Rhonda Hewer. Michelle is going to be monitoring the chat, so if at any time you do have questions, plug them right in there, and then she will either address them in the chat or we will make sure we address them at some point in the slide deck. And if any of you are from distance learning, you're going to recognize Hebron there and be asking, why is he in junior? He does support intermediate distance learning, but he is currently in junior for the just-in-time math PD. So today we are hoping to accomplish all 4 of these things. We will see if that's going to happen. We're going to talk a little bit about the connection to the number strand as we're working our way through the data literacy topic. We're going to explore some math talks that you can be using during this topic, and then just a general layout of what your data literacy weeks could look like. And then, of course, we did put a Slido out there where we're always anxious to see what questions you have, or you can upload other people's questions. That happens for every just in time. So we will take some time to address any of those questions that you might have there. So we're going to do a little data talk to start things off. This is your minds on. I want you to put your thinking in the chat. We're not going to do the 3, 2, 1 waterfall just yet, but just your thinking in the chat. What do you notice and what do you wonder about this graph?
Rhonda, do you not want to use the Jamboard?
Not yet.
Okay.
Eventually, but not for this Notice Wonder, for the next Notice Wonder.
Okay.
I'm just going to come back. Oh, what happened there? I'm going to come back to see what people notice. The amount being observed is decreasing. Wondering what the graph is representing. That's a great question. It's on the x-axis, aka what are we looking at? Great. Is that, Chad, can you mute your mic?
Sure.
Thank you. Why are they all blue? Chad is wondering. Okay. So all really, really great questions. This makes us realize, you know what, a graph's no good if we don't know the information that's coming with the graph. Somebody mentioned that they're noticing that it's decreasing as we move to the right. And if we are looking at these 4 bars, so I want to talk a little bit about looking at something in an additive way versus in a relative way. So when I say relative, you might also hear that term in connection with proportional reasoning. You might also hear it as multiplicative thinking. Really, relative means I'm thinking in a way that's involving relationships between 2 things, whereas additive is thinking like something's just more or less than something else. So if I told you that one of these bars one of the 3 bars on the right has 5 less than the first bar on the left, what would you assume about the sample or population size? So I'm going to say that again. If we're looking at the 3 bars on the right, and I said one of those bars has 5 less than our very first bar, what would you assume about the population size? So you can think about it in each situation. So if the second bar had 5 less, what would that tell you about the population size? If the third bar had 5 less, and if the fourth bar had 5 less. And again, just type your answer in the chat. We'll take a look at it in the chat.
And then maybe get somebody to explain their thinking.
Perfect. Actually, do you want to do that, Michelle, if you see something coming up in the chat so I can keep this up here?
Yeah, so actually, I'm going to get Ryan Roth. He said it's relatively small. So Ryan, tell us about that.
You don't want me on mute, and I got 3 kids in this house. Who knows what's going to be going on in the
That's
background?
okay.
You said one of the bars was 5 less than the ones on the right, so I was looking at that going, oh, it's a little bit over half. So I'm thinking those larger bars are probably a little bit over or close to 10. So I was doing a little bit of quick mental math and suggesting that the total sample size, if those are each 10, and I take the 2 smaller bars as being 5 and a little bit less, are somewhere around 30. That was my thinking behind it. It was all estimating.
Yeah, thank you. And then Amanda, can you explain? Amanda has said the population could be a large range.
Yes, I was looking at the second bar from the left, and if that was 5 less, then the other ones, then the 3 bars would be, it would be a lot.
Why? Why would they be a lot?
Well, if, for example, if the far one on the left was 100, then the one to the right would be 95. Or if the one to the left was 1,000, then the other one would be 5 less than that.
Okay, thank you.
That was good. I like the music soundtrack for that one. So awesome answers. And what we want to think about here is that if I'm talking about 5 less, then if I have 1,000 people in the sample, 5 less doesn't really mean too much about the data that I'm looking at. If I have 10 people in the sample, 5 less tells me quite a bit about the sample that I'm looking at. I want you now to, that was thinking about it in additive terms. I want you now to think about it in relative terms or multiplicative or in a proportional way. So if we were comparing the bars on the outside, so the very first bar and the fourth bar, so the bar on the left and the bar on the right, how would you describe the bar on the right in comparison to the bar on the left? And again, just use that chat.
So I'm seeing a lot of 1/3. I'm seeing a little less than 1/3, about 1/3, at least 1/4, just under 1/3.
Awesome. So that's telling us a little bit more about the data that we're talking about, because now we can talk about it in relative terms. 5 less, I had to do like a lot of assumption thinking. And again, this could be a population of 10, this could be a population of 1,000, but now knowing that 1/3 of that gives me like kind of a better visual of what we're talking about. What information would be useful for you to be a true critical consumer of this data? So what information would you like to have? Write that in the chat.
So we're seeing Steve would like to see some y-axis value. Chad would like to see labels for the x and y axes, the values of the axes, Trisha's saying.
Excellent. I can give you that information. So this, I'm going to give you that information now. And Michelle is going to put in the chat a link to a Jamboard where you'll also see this graph. And I want you to write down now what you notice and what do you wonder about the graph. So here is that information that you're asking for. And boot on over to that Jamboard and just jot down some notes there. Record your thinking on that Jamboard. What do you notice? What do you wonder? Actually, you can go to the Jamboard. So if you could put what you notice, make your sticky green, and anything that you're wondering about, make your sticky blue, and you can grab, just on the left is the toolbar. You can grab that one that kind of looks like a folded piece of paper. Somebody's really excited about making that graph big.
You gotta be able to read it. It wasn't me.
So far, not a lot of noticings and wonderings.
We have one in the chat. So Trish, can you throw that on a sticky note of something you're noticing? Since it's a noticing, can you put it on a green sticky note?
I think Chad maybe wrote over the blue one. So one thing that's really important when you're doing a data talk is this wait time, and it feels super awkward, but it's super important. And I think on average, what do teachers normally wait? Like 1.6 seconds or something, I think, is the average wait time for teachers.
Yeah, some really small time.
Yeah, it's a very small amount of time. Don't they say you should wait like at least 7 to 10 seconds?
No, 30. And
30
that's why it feels so long.
Yeah. Now we're getting it. Look at this.
Mm-hmm.
Really great questions. Why doesn't everyone do summer school?
So my observation is that we made a lot of noticings, but we didn't necessarily record our noticings, and we recorded our questions because we've jumped already to the questions.
Mm. I noticed Chad Harris is getting a little sassy. Okay, so I think we're going to take a moment now just to discuss this a little bit. So this is our board. So for all of WRDSB students in grade 9, our research department tracked their progress for 3 cohorts. And that was just because somebody asked a question, why is it only for 3 cohorts? That's just whatever we had data available to us at the time. And then also understanding that we've gone through some recent tricky years. So there's a lot of variables in there beyond what we were trying to look at. So 8 credits is how many credits you should get in a typical grade 9 year if you were taking a full course and you were passing all of them. And as you can see here, we have some pretty major concerns, and somebody noticed right away before you even had numbers connected to the axes that this is significantly decreasing. So we can see that if a student in grade 9 does not have their 8 credits by June, so they haven't got at least 1 credit or more during the course of the school year, and they didn't bother taking summer school, only 25% of those students graduate within 5 years. So they've extended it to 5 years because if we looked at 4 years, there's a lot of students that choose to do an extra year, so that data would be a little bit more skewed. So we can look at 5 years and get like pretty much the whole cohort. So this is a big problem for us at WRDSB. And one of the things that we need to think about as grade 7 and 8 math teachers is one of our biggest barrier, if not the biggest now, barrier course is grade 9 math. So we need to think about what we're doing to help prepare these students so that they're going to be successful when they get into a position of grade 9 math, because there is no longer any modified IEPs. And next year we know that we're going to a de-streamed model. So there's not even like a let's put this child in applied, which by the way was a super rigorous program as well. So it's not like we're just putting them in there because they lack a lot of skills. They need to have a lot of skills. So what we have done, and I'm sure most of you have already heard about this. So if you wanted to come back to the presentation window, the Google Meet, we have identified 4 areas that we're referring to as the non-negotiables. And this has been based on EQAO scores, looking at the secondary curriculum, talking to secondary teachers, working with secondary students, student success teachers, spec ed teachers in secondary. And it comes down to, for the most simplistic way that we can describe it, these 4 areas: order of operations with fractions, order of operations with integers, proportional reasoning, and algebraic reasoning. And if our students don't leave grade 8 proficient in these 4 areas, they are going to struggle significantly. And if it doesn't happen in grade 9, it will happen either grade 10 or grade 11. There is a brick wall in math that happens usually as students enter grade 11. So they might be doing really good grade 9 and 10, but it comes back to these foundational concepts. And there is, at this point, we haven't had a chance to see what the new curriculum for secondary is going to look like, but at this point, there is no more units or like no more direct teaching about fractions or about integers once they are in grade 9. So grade 7 and 8 is their last chance to really perfect and become proficient with these concepts. So when we are looking at the topics that we're moving into, so we're moving into the data literacy topic, we don't want to look at it as just teaching data literacy. We want to look at it as how are we teaching those 4 non-negotiables through this topic. And for data literacy, we want to think about using the lens of proportional reasoning to address the data literacy concepts. And I hope that makes sense. So it's like thinking of data literacy as providing with you context for addressing those proportional reasoning skills, or that data literacy is the vehicle through which proportional reasoning will be taught. And when we look at the LRPs, the long range plans, this is all the specific expectations for grade 7 and grade 8 for the next topic. And you can see that some have been pulled out from number. And you're going to see that quite frequently in many of the topics. And this is to, number 1, revisit these 4 non-negotiables so that you're coming back to them all year long. And we've tied them so that they're actually complementing the topic that you're going into. So we are focusing hard on percentages as we're teaching data literacy because it lends itself really well to this topic. And then I was looking at the data literacy expectations here, and I was like, okay, I'm going to highlight for them which exact data literacy top expectations are also addressing proportional reasoning. And here's what I found. Every single one of them actually has proportional reasoning in it. And it is our job as a teacher to continue to make that explicit to students. So if I'm looking at the grade 7 side, I'm explicitly talking about percentages in the first 2 expectations. When you're talking about circle graphs, which are in many of the other expectations, you can't do circle graphs without a good understanding of proportional reasoning. And then D1.5 really lends itself to a great conversation of additive thinking versus multiplicative thinking and how each could be used appropriately. So if I'm changing a number in a data set and I'm thinking about the mode and the medium, that's an additive way of thinking about it. It's not going to change in a relational way, but the mean will change in a relational way. And if you have an outlier, that's going to significantly skew the mean. And if you take that outlier out, what is going to happen to that mean? And when you're looking over at the grade 8 data, you're looking for relationships between two variables. So for example, if I were collecting height and arm span from the same sample to see if there's a relationship between those two variables, I'm looking for a ratio, which is proportional reasoning. So generally arm span and height is like a 1-to-1 ratio. So you're looking for relationships between two variables. And when you're looking at a scatter plot, you're looking for a positive or a negative linear relation, which is proportional. So there's some sort of rate of change in that, or no relation at all. So proportional reasoning was already embedded in data literacy. It is your job as a teacher to continue to make that explicit and label it for students. So, oh, this is a ratio here. Did you know that percentage is actually a ratio? Like, let's look at these things and start to develop the proportional reasoning skills. Okay, so let's move into some math talks. So the first math talk we're going to do comes from the mini lessons for operations with fractions, decimals, and percents, which is a Catherine Fosno Green Book. And all grades 7 and 8 schools were given this book through their math leads at some point in the last 4 years. So hopefully you still have it. We are going to use the ratio table right now. So if you have like a pencil and paper handy, or you don't need one, whatever, this is actually, yeah, I'm just going to get you to think about this one. You don't necessarily, yeah, we do want to put this as a waterfall.
Mhm.
Oh, there's that waterfall icon. Okay, so we are going to do this as a waterfall again. Sorry. So half of 240, write that in the chat, but don't press send yet until I do my 3, 2, 1 waterfall. So just write it in the chat. What would be 1/2 of 240? And 3, 2, 1, waterfall.
And we got a big waterfall of 120.
Awesome. Okay. So how would we use a ratio table? So your job as a teacher is to capture the thinking of students right now and somehow make a visual display of it. So if we were using the ratio table as our tool, which is what this particular number string has been built to complement, this would be my ratio table. I would be asking students, well, how did we get that? Well, we thought about, what do I have to do to 1 to go to 1/2? I have to divide it by 2. So I have to do the same thing at 240. I divide it by 2 and I end up getting 120. Okay, here's your next one. Again, type her in the chat. Don't press send. And 3, 2, 1, waterfall.
We got a whole bunch of 120s.
Yay! Okay, so same idea here. The number string has been crafted specifically so that 1/2 is connected right beside 50%. So we can have that conversation that 1/2 actually is 50%. How do you know that? How are you sure of that? And this is starting to make that connection. We've all seen that expectation where you want them to convert between fractions, decimals, and percents. This is a number talk that allows them to start getting familiar with that thinking. So again, it's going to be the same. So there's my 120. Okay. Here we go again, 25% of 240. Put her in the chat, but don't press send.
Give them a minute to think, Rhonda. Not a minute. Literally.
minute to
Give them
think.
2 seconds.
I am going faster with this than you should with your students because I feel I have the gifted group here today. Okay. Actually, I shouldn't say that because gifted groups also need think time.
True.
Okay, 3, 2, 1, waterfall.
And we got a cascade of 60s.
Yay! So once again, we would go back to our ratio table. We would ask them, how did you know that that was 60? Some of them might have lots of different reasons for that. They might look at the 1 and say, I can go from the 1 to 25%. I know 25% would be 1/4 of 1 or 1/4 of a 1. So then I do the same. Generally, because the string has been created that they're already thinking 50% was this. So 25% is half of 50. So I would take half of 120 and I would end up with 60. Okay, so go ahead, 12.5% of 240. Write it in the chat. And 3, 2, 1, waterfall.
A cascade of 30.
Yes, you're so brilliant. That's amazing. Okay, so same idea. We would look at how did we get there, and we would end up at 30. Now, the first three problems in this number string, and generally number strings always, the first three are really easy, accessible ones because you're using them to scaffold the more complex number strings that are the more complex problems that are going to come later in the number string. So they make them very accessible in the beginning. Here's the rest of that number string. I'm not going to ask you to actually do it, but just think about maybe how you would do it, because I'd rather us talk now about the teacher moves that you would need to make this, to pull the math out of this kind of thinking. Okay. So in that green book, so I'm just going to actually go back here. This is the green book up here. So hopefully you've seen it in your schools. If you haven't and it's disappeared, ask your admin to buy them an extra copy. I think they're only like 30 or 40 bucks. They're not horrible. And it's laid out beautifully. It comes with all sorts of an explanation for each number string. And I know as teachers, we generally like to skip those things over, but it is kind of important that you take some time to read those because it will outline for you what is the purpose behind the string? Why has the string been created like this? So for example, in the set of number strings that this number string has come from that you're working with now, this is a talk that has been pulled because it's using a fraction as an operator on a number other than 1, and then juxtaposing it with a percentage or decimal equivalent. So eventually you would continue to do these, and they would progressively include decimals. So for example, that, like I said earlier, the half of 240 is right next to 50% of 240, and that supports the student's ability to interchange those two. And then it also allows for partial products, which we're going to see in the last part of this number string, so that students can be making these partial products and then combining them to determine products of less friendly fractions or percents. So for example, 37.5% of 240 is a difficult percentage to calculate, but it's easy when you're thinking about it as 1/4 of 240 plus 1/8 of 240, or 25% of 240 plus 12.5% of 240. So that's called partial products. So what I'm going to do now is Michelle's going to put a link in the chat. This is a link for you. It's a transcript of how a teacher might interact with his or her students on this particular number string. And I want you to read this, and then I'm going to put you into breakout rooms of about 4 people. And I want you just to discuss what were the teacher moves that you noticed that helped the teacher pull out what the big idea about this number string was. So it's not just about the answers. The whole point is we're trying to connect percentages and fractions. So what were some of those moves that they did that allowed that to become explicit for the students? And I'm going to just go over here. Where did we go? There we go. Okay, so it's in there. I'm going to stop sharing for a moment. And I'm going to give you a breakout room. And as I'm doing that right now, you're just reading that transcript.
Oops. Sorry.
Okay, so soon you should see an invite to the breakout room. Actually, there we go. Oh, I was just texting you.
Can you reassign me?
I don't
Reassign
know.
me.
Oh, maybe now that you're out, I can. Let me see.
Yeah. Yeah, that's why I came out.
I don't edit rooms. Okay, here we go.
You just dragged me.
Oh, I do?
I think so.
Poor Steve was by himself forever too. Okay, I threw you in one. I'll throw Minu in another one. There we go. Okay. Get rid of breakout 4. Did it show up?
No.
Oh, wait, I gotta save. There we go. Okay. Like, do we have everyone back? I think. So I wasn't really able to join a room. Michelle, were you able to join a room and hear anything of interest?
I was, and yes, it was all of interest. So some of the key things that were shared in the breakout room in which I was eavesdropping were the fact that the teacher, one of the big moves the teacher used was to use the fractions, decimals, percents interchangeably. So not just focusing on the one, and being very intentional about that, especially when asking students to explain their thinking, like rephrasing it using the percent and or fraction, whichever one the student didn't use, to help consolidate those connections. And then the other thing was another teacher move was encouraging the students to think about previous information that might help them and giving them a chance to practice right away what the new learning might have been with the next part of the string.
Yeah, that's excellent. I really like, there's that one line in there that it says, you've reminded us of the fraction equivalence of 12.5% and 25%, like her reiterating what the students have said in words to make sure she's highlighting that important point. So those transcripts are throughout that book. So super handy for you to read and get a gist. I mean, clearly it's a script, so it's not going to look like that in every single classroom, but it does give you an idea of how you can kind of take control of the conversation using the student thinking. Okay, so the next number talk that we want to do involves a bar model. So students can relate to percent comparisons in progress bars really well. They generally, what they'll do is they'll find friendly percents and then either scale up or scale down, and you're going to see that in a moment. And this is very similar to a double number line, which students are becoming more and more familiar with and that we use in fractions all the time. So it's kind of connecting different models. So we tend to ask percent questions in one of three contexts. So we have like the start unknown, which is when you're given the percentage that you want to find and the total amount, and you have to find what that percentage is. There's the percent unknown, which is when you are given two numbers, but you have to figure what the percent of one of the numbers is of the other. So again, this is a ratio. 16 to 40 is what to 100. And then the result unknown. So I know what 6 is, and I know 6 is 50%, but I don't know what it's 50% of. So those are the three different contexts that we tend to use. And this book that you see in the top right corner there, Lessons and Activities for Building Powerful Numeracy, was also given to every single grade 7 and 8 math lead 2 years ago. So you should have a copy of it in your building. It is excellent. It's got a little bit, it starts to go into some more complex math that we want to see in grade 7 and 8, whereas the mini lessons, really it's only the green book that's super effective for 7 and 8. So what I'm going to show you is a workout. They're called workouts, but they look a lot like worksheets. And the workouts are a result of teachers asking for conversation starters for students. And so the point is that the discussions that follow the students doing the workout, actually, let's see one. So we're going to go to Google Slide Deck. Michelle's going to put a link in there for the Google Slide Deck. And we've done this before in our sessions. So we're going to use this as like a vertical non-permanent surface. So we'll just look, once you get into that, I want you just looking at the master slide for a second, because we're going to talk about the workout before I have you go work on the workout. So it looks like a worksheet, and the discussions that follow students having think time on the worksheet are critical. So it's not intended as a worksheet that students complete and then hand in, but instead as a starting point for some discussions that help students build those important relationships and choose those effective strategies. So after the students have worked on the workout for a few minutes, the teacher would then lead a conversation to help them compare the strategies and discuss when it might be most efficient to use each one. There are other workouts that present students with common errors and then ask them to analyze the errors, or provide students with a model and then scaffold to help them begin to use the model as a tool. So this is just one example of what the workouts are. So to try and demonstrate for you how you would use this workout, we're going to do a little bit of role playing. So I'm going to ask for like 4 or 5 teachers to unmic and be my students, and I'm going to be the teacher. So if 4 or 5 of you go back to the Google Meet and just unmic. I'm hoping there's some people volunteering. Just say hey if you unmic so I know.
So we got
Hey,
Hey.
Okay, awesome. You guys are so brave. Thank you
Steve
so
and
much.
Amanda.
Hey.
Fantastic. Okay, so my students and the rest of you are just fishbowling this conversation. My students, here we are in math class. We've done some workouts before. What is going on in this workout? What do you think is happening in this workout? And just talk, because I can't see if you've got your hand up.
Are we looking at the whole sheet or just the first one?
Yeah, look at the whole sheet.
Okay.
so I see that it's I see that there's different percentages on there. So I see that the first one has 1%, 10%, 90, 91, and 100. And if you look at the bottom, I see that it's out of 60.
Yeah. It looks like all of them are out of 60, right? So it looks like we're going to be finding percent of 60. Very good. Who was that? Steve?
That was Steve.
Way to go, Steve. You earned that tuxedo today.
Thanks, Rhonda.
What you are looking at is these are examples of how some students in a different class have completed these problems. And you're going to be asked to fill in the boxes to see how these students found these percents. So really on the sheet, it's blanks, but I've added just text box here. This was like a total, I just took a picture of this worksheet in the book. I plugged it in here on Google Slides, and then I add text box so that you could enter in your numbers here. So do you think that you're going to fill in the boxes in order? So if I'm looking at the first one there, I see 4 boxes. Do you think you're going to fill them in going from left to right?
I won't. I'm just going to work with the benchmark fractions that just work best for me. So for example, I know that there's 100% out of 60. If I'm looking at number 2, I know that 50% will be 30. So in that box, I'll just put 30 right now.
Excellent. Right on the master slide. Way to go.
Sorry. I'll
You didn't earn that much of a tuxedo. Take that
yeah,
back.
there you go. I'll take it back.
But you're absolutely right. If you can't figure out what goes in a box, then you might need to look at the other boxes on that percent bar. And then maybe the ones that you have filled in will help you with the others. So really, really good point there once again, Steve. So go ahead, everybody. Grab a slide. Write your name on it. And I want you, and so now this is for everybody in the room, not just my 4 or 5 students that I'm working with. I want everybody to give this a try. So grab a slide, put your name on it, and if you have never seen this, you can come back to the Google Meet, and you can see my screen I have in grid view, so I can use it like vertical non-permanent surfaces, so I can see what people are doing.
And Amanda, if you don't mind to mute again during this part, please.
Is that Amanda who has a little one?
Must
I
be.
do.
Oh, yay!
Sorry.
There's, you know, it's never too early to learn about percentages. I guess I was a little ambitious with how many slides did I make? 30? Figured what else would people want to do on a snow day but come and listen about math? Okay, so I'm seeing that most of you have completed it. So if I could have my 4 students on mic again, I'm going to kind of demonstrate for you how you would consolidate this. So it's not just handed in and you see whether they got the right answer. It's about hearing the thinking that's happened and having other students connect with other students' thinking. So remember our initial question was how could we consolidate this so that it isn't just taking up the answers? So my question is, if I'm looking, I'm going to go back out of grid view. If I'm looking, sorry, hold on 1 second here. I should have had this before I started talking. Okay, if I'm looking at that first question, how do you think the student found 91% of 60?
They found 10% and then 1%.
And then?
So they multiplied their 10% number, which was 6, by 9, and they found that it was 54, and they found that 1% was 6/10. So they added their 90% and their 1%. So they added their 54 and their 6/10, which would
Excellent.
be 54 and 6/10.
Excellent. Thank you very much. And then so far that was pretty easy. But what about the 125% of 60? Let's skip down to that one. Those first two, I think everyone's got a good handle on. What about the 125%? And now this is just a side note. I wouldn't say this to my students. I'm saying this to you. Know that this bar that we're looking at right now is a grade 8 expectation. So in grade 8, they're looking at going above 100%, and I think below 1%. So you wouldn't necessarily use this bar with grade 7s. Okay, so what about 125% of 60? Who can help explain that one? And of course, while somebody's explaining it, I would either be using a document camera or the whiteboard to document their thinking.
So I know that 60% is, sorry, 60 is 100%. And then if I and then if we figure out what 25% is, so a quarter of that is 15. Yes. So then I would just add 60 plus 15, which would be, which would be 75.
Right. And this might not be accessible to some of your students yet. So they might actually want to put, a line right in the middle of the bar and figure out what 50% is so that they can go like half and half, whatever they need to do.
Mm-hmm.
Awesome. Great thinking.
Yeah. And I know that some students, I've seen them use like a fraction, like the fraction towers, and just put a line through that.
Oh yeah, that's a really great strategy as well. Like making it visual is awesome.
Yeah.
Okay, and let's share some strategies for the last problem, finding 40% of 60. What was the thinking going on there?
For me, I figured out what 10% was, and I knew that was 6, so I just multiplied that by 4.
Excellent.
To get to 40%. So I added on and used repeated addition or just multiplied it by 4.
Yeah, that 10% is really handy. What other percent might 10% be really handy in finding for other problems? Like the first problem. How did we use 10% in the first problem to find another handy percent?
90?
Yes, we did find it for 90. Was there another percent that we wouldn't maybe have been easily able to get if we didn't find 10%?
Oh, the 1%?
Yeah. So pointing out, thank you students very much. That was the end of our show today. Not the end of our session, that was just the end of the theatrical production there. Pointing those things out for students, like connecting that 10% to 1%, you've just now given them a strategy. Like if I can figure out 10% and I can figure out 1%, I can almost figure out any other percentage that you're asking me to figure out. So thank you for humoring us. And if you want to come on back to the Google Meet window now, I'm going to present again. And this is a reference slide for you. I'm not going to go through it. Whenever you see that little book icon in the top right, that just means this is for something for you to use as a reference or go back to later. It's just some questions that might help you try and guide that consolidation of learning. The other piece is you can use that bar model to do a string like we did with the ratio table, where you're just giving like 100% of 15 and letting them draw a bar model, and they would figure that out. And then the next problem you would show would be 50% of 15, and they would show where that's going to be on the bar model. So this can be used as a tool for them to be able to show their thinking about proportion. Again, another reference slide. The big ideas of data literacy that we really want to focus on as we're teaching it is not whether they can calculate the mean, median, and mode. It's not whether they can create a graph by hand. It's, are they a critical consumer of data, and how do I teach them to be a critical consumer of data? And what story is the data telling, or what story do I want the data to tell? And you're going to see in our new curriculum that it really emphasizes using infographics. This piece about being a critical consumer of data, UCubed has the most amazing resource out right now. We are really happy with it. We really like it. If you go to UCubed, you can see right here, there's data talks, but there's also lessons, which Michelle's going to talk about in 1 minute. These data talks are fantastic. So the kind of like the data talk that we did at the beginning of our session today, you could pick any of these graphs. This is an amazing one. This is Stephen Curry's hits. Is one of the best. This is all his shots and his progress. Throw something up like that. Have a what do you notice? What do you wonder? If you're not sure what that should look like, sorry, I shut it down here. In Data Talks here, there's a video of a teacher doing it. It's a 2-minute video. You can watch that and see how she navigates the conversation. And then there's also a PDF kind of explaining what the data talk is. So that's going to be an awesome resource for you to be using. And again, another reference slide. What is your role as a teacher during math talks? What is the role of the student? You are giving think time. You are making the student thinking visible, and you are making connections between different strategies for students. The role of the student is to participate, to share their ideas, and to build off of each other's ideas. So I'm going to hand it over now for the last 5 minutes to Michelle, who's going to kind of walk you through what she has very graciously created for you.
Okay, so I just put the link in the chat. Rhonda, if I could get you to actually click on that link in the presentation, please.
Yes.
And then go to Fit. So under View, if you go to Fit.
Okay, yeah. Look at what we're learning here today.
Oh, how come you don't have Fit?
I don't know, is it here?
Oh yeah, there, sorry, my bad.
Okay.
Okay, so first of all, I just want you to notice that just like with previous weeks at a glance that we have shared, we are looking at about 2 to 3 math talks per week and about 2 to 3 purposeful practice opportunities per week. Now, I have relied heavily in creating this on the UCubed lessons that Rhonda was just talking about. So on the first day, I'm doing a little bit of a diagnostic. I want to see where the students are at. And that accesses another really good resource for graphs, which is Turner's Graph of the Week. So I'm not going to get Rhonda to go there right now, but Turner's Graph of the Week has just what it sounds like, a graph every week that they have found online with some questions. And the whole purpose is, what does the data tell us? What do we see? What do we wonder? It's very similar to the data talks, except that it has students go a little bit deeper, and it's a handout. And the most recent versions of those graphs of the week actually have a Google Doc version, sorry, that you might use if you're doing distance learning. What I am going to get Rhonda to do, though, is on day 3, Rhonda, can you click on US roller coasters, please? So the UCubed lessons rely heavily on this website, which is called CODAP. I forget what the acronym stands for, but it's basically data. And the nice thing about this, if those of you that are old enough like me to remember Tinkerplots, some of the same data sets are here as in were Tinkerplots, as were in Tinkerplots. And you can see on the right there that leads you right through. So you as a teacher, if you're exploring this, it tells you some things that you can do to explore this data set, including dragging some of the attributes to create different graphs. If you just click on one of the random dots in the middle, yep. So when you click on one, it shows you in the table which roller coaster that is, and then you can scroll to see all of the data about that roller coaster. So again, we don't have time today to explore this, but it's a really useful tool for students to explore, analyze, ask questions about data, and to see different representations and graphs of data. So we can go back to the sample week at a glance, please. The only other thing I want to point out here is, just as we've done in the past, there are things that you want to try to notice about your students as they're doing this. So this whole first week is mostly focused on getting students familiar again with looking at data, analyzing data. There are a couple of data talks. And then in the subsequent weeks is where I would have that heavier emphasis on the number talks that you just experienced with Rhonda. So back to the presentation, Rhonda. So after you've seen that first week, the second and third weeks, because we're thinking it's going to take about 15 plus days, that's what's been allocated in the long range plan outline. Once students have had all of this exposure, they've seen a bunch of infographics. Now we can think about, well, what makes an effective infographic? Based on the visualizations that were shared during week one, as a class, you can create some success criteria. And just a little suggestion, using a Frere model, like what's a non-example? It often helps students to think about what an effective infographic is and is not, in order for them to be able to create their own, which is one of the main expectations within the curriculum, and also what we think might be a good thing to introduce in week 2, so that students can identify a topic or issue, collect some data, and the whole point is to create an infographic that helps to tell a story. So they would have to consider who's their audience, what's their purpose, are they trying to persuade, are they trying to inform? Looking specifically at the curriculum, you might want to have as an expectation that your grade 7 students include a circle graph, or if you're teaching grade 8, that they include a scatter plot as part of their infographic, and then they would have to include the other class generated criteria. In that first week at a glance that we've provided, students dabble in that. So they, as a group, create some visuals for some of the interesting data that they see in those CODAP data sets. So that prepares them to be able to do this on their own in weeks 2 and 3. Any questions about the week at a glance or the 3 weeks?
Michelle, you said that it was for 7 and 8. Did you say that? I don't know if you did.
I did not make that explicit. Yes, so that first week at a glance is appropriate for both grade 7 and grade 8, and it's here in weeks 2 and 3 that you would hone in on those specifics in terms of the types of graphs. And day 5 of the sample starts to look at measures of central tendency. And there's, again, just a fine distinction between grade 7 and grade 8 that you would try to make with your students following up in weeks 2 and 3.
I do have one quick question. I've heard some rumors, and I guess we talked about in the last PD, that we might be at different stages as distance ed. And I just don't know if that will be addressed, if we need to throttle down a little bit, or because from my understanding, I think distance ed, most of them are a little bit further behind in class.
So what do you mean, Stephen, in terms of throttle down?
I just heard some rumors and that they might try to readjust the schedule come February. So I guess that's all just speculation about trying to make sure that everyone's all at the same level at the same point.
Yeah, so I think the thinking behind that is that the beginning of February is another, or mid-February is another transition date where students might transition between face-to-face and distance learning, and that we would want teachers to be in a similar place. But I think the reality is going to be that no matter what students you end up with in front of you after that transition period, those transition days, you're going to have to pick up wherever they left off. There's no way we're going to get a whole system on the exact same page. So to the best of your ability with your students, if you can try to align roughly with the long range plans, that would be helpful just for everybody.
Okay, perfect.
Okay,
All good?
I think so.
All right. So Michelle, that's amazing that you created that week at a glance. I think that's going to be super helpful for everybody. When you're thinking about the infographics, these are some useful tools or manipulatives and visuals that are going to be handy, as well as when you're doing percentage talks or data talks. We know there is quite a few vendors out there that provide infographic templates. We are saying you need to be very careful when you are using third vendors. We do have a WRDSB policy around using third-party vendors, not third vendors. And you need to be really well informed about their privacy policy, because you are actually putting students' personal data out there. So I'm just saying that that's where I'm going to leave that. So these are great things that they can be using to create their infographics. Oh, I'm sorry, I didn't realize that this was a transition slide. Little surprise for everybody. Another reference slide for you to read later. What are some reasons? This comes from Leaps and Bounds, which is an excellent resource for gap closing. Why might students actually struggle with data literacy? You can read through that to see some reasons behind that. And our strategy harvest today, these are some things that we've used to try and engage you as a learner. The 3-2-1 waterfall, the math talks to build fluency. We've incorporated visual cues on our slides when it made sense to. We did some vertical non-permanent surfaces. We are always trying to bring as much visual into the mathematics as possible. Not conceptual understanding of equivalency. I didn't clean that up from algebra. And then we did use Slido. Our next just-in-time session will be in January. We were holding off on a date because we wanted to see from that first slide where all of you were gauged at, and you are pretty much where we expected you to be. So we will be communicating to you probably later in December before our winter break when that next date will be. And just so you know, it's always the same Google Meet. So it's always going to be the same Google Meet link, if that's helpful for you. And that's it for us, unless you've got some stuff on your mind. I apologize. We went 5 minutes over. That was my fault because I like to chat on snowy days. Yeah, anything that we need, any pressing issues that you would like to take this opportunity to discuss? There was nothing in the Slido, right, Michelle?
That is correct. I just double checked. And in the chat, I'm seeing some thank you. So we appreciate your thanks and appreciation.
Excellent. The slide deck and the recording will be posted on the long range plans, as well as the week at a glance. By tomorrow, it will be posted. Cool.
We're cool. I'm just seeing a bunch of thanks. So thank you, everyone.
Yes, thank you very much for joining us today. We're thankful for that. Great. Everybody have an excellent night, and we will see you at some point in January. Happy mathing.